Okay, these notes are going to go into your AP Bio composition notebook. It's investigation number 7. The broad question is, can the heredity of an organism be determined using phenotypic and genotypic data? Can the heredity of an organism be determined using phenotypic and genotypic data? The much more realistic question, the question that we absolutely can answer by doing this lab activity, is which ear of corn is the F2 offspring and which one is the back cross? So when we draw our conclusions, this is the question that you are answering. This is what you're answering to make your claim. All right, some things that you need to know. Purple seed color is dominant to yellow. Smooth texture is dominant to wrinkled. P1 genotype, parental genotype, we're going to have a pure breeding cross. So the genotype is going to be all capital crossed with all lowercase. Capital P, capital P, capital S, crossed with lowercase p, lowercase s, lowercase s. So one homozygous dominant parent crossed with one homozygous recessive parent. So the phenotype then is purple, smooth, crossed with yellow, wrinkled. So this was the P1 generation cross. We do not see those ears of corn. I do not have those ears of corn for you, but you do need to know that in order to get to the F1 offspring, we had to have had the P1 that was purple and smooth crossed with yellow and wrinkled, and they were pure breeding individuals. All right, so the offspring of this parental cross, the F1 generation, all of the offspring are going to be heterozygous for both characteristics. So they're going to be capital P, lowercase p, capital S, lowercase s. The phenotype is going to be purple and smooth, and that's for all of the offspring. Okay, so an F2 individual would be a cross of 2 of these F1s. A back cross individual would be taking one of these F1 offspring and then crossing it with one of these parents. Let me see if I can get my little laser pointer that way to show up a little bit better here. Okay, so F1 means that we took these 2 parents, we crossed them, and then this is all of the offspring that we got. All of them were purple and smooth, heterozygous for both traits. We don't see these ears of corn either. We don't see these. We don't see the P1, we don't see the F1, but you need to know that first we had these, we crossed them in order to get these, and then we had these, and we either did an F2 cross or a back cross. In order to get F2, you need to cross 2 F1 individuals. So that would be 2 of these heterozygous purple smooth crossed together to give us an F2 ear of corn. The back cross means that we're taking one heterozygous purple smooth, and you are either crossing it with a purple smooth individual or you are crossing it with a yellow wrinkled individual. So not only do you have to decide which ear of corn represents the F2, which ear of corn represents the back cross, but when you choose which ear of corn is your back cross ear of corn, you have to tell me this back cross ear of corn was an F1 crossed with the purple smooth parent, or this F1 back cross was back crossed with the yellow wrinkled parent. So you have to indicate which parent the back cross was crossed with, an F1, and which parent. Okay, so underneath the information, or underneath the information that you just wrote, we need a hypothesis. You're actually making 2 hypotheses. So which ear of corn do you think is the F2 ear of corn? The F2 ear of corn is number whatever. The back cross ear of corn is number blank. It was back crossed with the purple smooth parent or wrinkled yellow parent, whichever one that you choose. So you have 2 sentences. One sentence is going to indicate which ear of corn you think is the F2 offspring, and one sentence is going to tell me not only which ear of corn you think is the back cross, but what were those two parents? We have an F1 and which other individual? Was it the purple smooth or the yellow wrinkled for the back cross? You're going to set up 2 pages because 1 page is going to be for your F2 information. So this is 1 whole page. I've divided it in half. So this is all of my F2 information. It's going to be the data information that I count. It's going to be my analysis. All that's going to go here. Then the second half of the page is going to be my conclusion. Then you have a second page. This is my back cross information, all of my back cross information, data, count, numbers, chi-squared analysis, and then the bottom part of that is for the conclusion. All right, for your grade for this assignment, you can either turn in your AP Bio Comp book into the basket, that's fine, or submit pictures, but those pictures have to be clear. If I can't see them, I'm going to take points off for them. You don't know whether the picture is submitted clear or not, you can click on it and open it up and see what I'm going to see. But if I can't see information, then it's going to be points off. So make sure that you double check the pictures you submit. However, either one of these is fine. All right, so when you submit your Comp book or when you submit the pictures, I'm looking for these 3 things. I'm looking for data. I want to see what was your counts, what was the data collected from the corn. It should be organized, nice and neat. A data table so that I can see what's going on. Do not just have numbers squirreled in there somewhere. Then you need an analysis. We need to do a chi-squared analysis on this to see if the information that we come up with is what we're expecting to come up with based on the parents that we chose. So for chi-squared analysis, we need observed and expected data. Observed data is obviously going to be your counts, the data collected from the corn, but your expected data, whenever we're doing chi-squared analysis, your expected data, if it's not given to you, that comes from Punnett squares. So you can use Punnett squares, or you can use the laws of probability to determine what you expect the numbers to be based on the parents that you chose. Then finally, I need to see a conclusion. Claim. You're going to write a claim statement for each ear of corn. So 2 claim statements, 2 conclusions. Make sure that you answer the question. D, data, list the important or relevant data. I do not need to see all of this data because it's up here. I need you to pick out the important relevant data and list it in your conclusion. What ratio did you use for the Punnett squares or for the laws of probability or for whatever your data is that you expected? What chi-squared value did you come up with? What critical value did you use? What degrees of freedom? What p-value? And once again, you're going to do that twice because you're doing it for both the F2 ear of corn and the back cross. And then you need to explain, how does this data support your claim? How does this data allow you to write that claim sentence? Then go ahead and continue on and tell me, did the data reject your hypothesis or did it fail to reject your hypothesis? Explain how you know this. This is different than just showing how the data supports your claim. This is more information. You have to talk about your hypothesis. What did you see? What was going on? Why did the data that you have reject your hypothesis? When we do the chi-squared analysis to make our claim, that's just doing an analysis of the null hypothesis. You put an experimental hypothesis. You said that ear number 75 is the F2 ear of corn. So the data rejected that. So ear number 75 cannot be the F2 ear of corn because, and tell me why it can't be the F2 ear of corn. Ear number 77 is the back cross ear of corn. So let's say it supports that. Well, it supports that because here's the parent that I have, and here's the F1. If I do a Punnett square, this is what I'm going to see, and my analysis supports that. But you have to explain how you know. So that's in addition to saying how the data allows you to make your claim. So make sure you have all of that information on your E.